Alright, so this video is essentially the second part of this question. We started in the previous video solving some basic free fall situations here, and we solved for how high the bridge is that Palmer was dropping the rock from. In finding that height, we use this equation here. We use the displacement, the vertical displacement, equals the initial velocity times time, plus 1/2 the acceleration due to gravity times the time squared. And so in this one here, part B, we're going to find the velocity of the rock just before it hits the water. So again, if we have the bridge here, you get the water down below, the rock is going to fall down, and right before it hits the water right there, that would be the final velocity. That's what we want to figure out here. All right, so again, we still know that it's falling for a time of 7.3 seconds. We still are going to use the acceleration due to gravity of negative 10 meters per second squared. We also know, as we mentioned before, that the initial velocity is 0 because we're dropping the rock. So that means it starts at rest when we do that. So again, we'll just use this equation here. The final velocity is what we are looking for. That is equal to the initial velocity plus the acceleration, but we're going to plug in g for that since it's free fall, times the time times the time. Alright, so let's plug it in. So VF, final velocity, is 0 plus negative 10 meters per second squared times the time of 7.3 seconds. Alright, so final velocity then is equal to negative, the 0 is not there anymore, negative 10 times 7.3 seconds. One of the seconds will cancel out, and so we get negative 73 meters per second. Again, the negative now is telling us that it is going down, so it's telling me which way, and a speed of 73. Oh, that was not very nice. So that means we have a final velocity of negative 73 meters per second. So it's a little bit more straightforward, right? Not as much stuff to plug in and calculate with as you do this, but we find out essentially, and we just drop something, we just need to take the time that it drops and multiply it times the acceleration due to gravity. All right, 10 meters per second squared. Again, don't forget, we could use negative 9.8 meters per second squared. Either is going to be fine for us